waste ആണോ? Okay. Okay, so I think the live stream is going on, and this is where today's class will be live streamed to. I have sent it in the chat box, and I'm going to share my screen to. Okay, so right, so the so today I want to give you your assignment number 2. Okay, which by when can you submit it? So first question is, by when can you guys submit the assignment? Friday? So today is Tuesday, right? So 16, 17, 18. Can you submit it as on 18 or 19?
Yes, sir.
18th is Friday and Saturday is 19th. When do you want to submit?
So can we do 19 midnight?
19, sir.
19. Okay, good. So I'm going to keep it as 19. Okay. Now, what is the question that what is the question that you want to that I want you to solve? That I want you to solve. So the question is pretty simple. Okay. It's called game of life. Okay. It is a simple game. Okay. To emulate or to what do you call it? To it does emulate single an organism and its evolution. Okay, so that is what I want you to do, and the question, let's just search for game of life. Just a second. Okay, so yeah, so if I go to Wikipedia, I'll be able to see that. So this is the game. Okay, so it's called Conway's game of life. As you can see, it's a cellular automaton. Okay, so game of life, also simply known as life, is a cellular automaton devised by the British mathematician Jordan Horton Conway. So that's why it's called Conway's game of life. Okay, so you can see that if you look at the rules, right, of the game. So what you need to understand is that in this game of life, what you have is a grid, a two-dimensional grid. Okay, and in the two-dimensional grid, each grid you can actually place a cell. Okay, now the population will thrive, that is the population of in that grid will live for a longer time if just a second, yeah, will live for a longer time if there are certain conditions, and the population will die if there are some other conditions. So that is what we mean by the rules. So the rules of the game of life is an infinite two-dimensional orthogonal grid of square cells. Okay, so that's the two-dimensional grid, each of which is in one of the two possible states. Okay, so each cell, okay, so you have to understand that the two-dimensional grid that is mentioned over here, it's actually a two-dimensional grid of cells, cell as in the living cell. Okay, each of which is in one of the two possible states. Either a particular cell is alive or the particular cell is dead, or populated and unpopulated. Okay, so it can be either live or it can be dead, or it can be populated or unpopulated. Every cell interacts with its 8 neighbors. Okay, so every cell interacts with its 8 neighbors, which are the cells that are horizontally, vertically or diagonally adjacent. So what does that mean? Let me just take the draw. Can someone please check whether the live stream is going fine? I think so.
Fine, sir.
Fine, great, thank you. So let us try to insert a table over here, because that will give us an idea about what is the neighbor and 8 neighbors, etc. Okay, so I have inserted a table over here. Let me make it right. So this can be thought of as a grid. Okay, over here, if I say that this is alive, okay, or this is the 0 0, okay, then this will be 0 1, correct, and this will be 0 minus 1, correct, and this can be
1 0.
1 0, right, and this can be 1 minus 1, right, and this can be 1 1 1, okay, and same way you have to find out the indexes for the other things as well. So it can be minus 1 and 0, right, and this has to be minus 1 and 1, correct, and this has to be minus 1 and minus 1, correct. So this would be the actual grid. So if we are considering this particular entity, okay, I am saying we are considering this cell, okay, then you can see that around this particular cell there are 8 cells, correct, 1 2 3 4 5 6 7 8. So in a 3 by 3 grid you will have total of 9 cells, but you are considering one particular cell. So this you are considering this cell, and this cell will either live or die depending on what are the conditions of the other cells. So that is what a cellular automaton means. Think of it in this way. Think of it as a microorganism or a microbe which has to either thrive or which has to either what do you call, either it thrives or either it dies off. Okay, so that is actually done by the rules. Okay, so the rules are like this. At each step in time, okay, now what happens in a normal world? Why is there it is called as time is the 4th axis or 4th dimension of the space? Because this is something that we want to visualize, correct? We want to visualize. Say for example, right now at 13:40 I am talking to you guys, correct? I am talking to you guys at 1:40 p.m. on March 15th, correct? And I am waving my hands in front of the webcam. Can I go back in time, or can I go forward in time, or is the time something that has some meaning to our existence? Is it the 3-dimensional world plus the time as the 4th dimension that we know about as time and space, right? So over here what exactly we mean is we have a grid that needs to be simulated for, let's say, so this is time, okay, I am just mentioning this is time. I think I need to, yeah, time. Okay, so we have to run this program for a particular period of time. So the period of time can be starting from t0. Is it t0? Wait. No, format, text, subscript. Subscript is control shift B. Okay, so from t0 to, let's say, then the next one is could be for t1. Okay, t1. Okay, so you have t0, t1, and then finally you might have let's say you will have tn, correct? So which means that you are going to have a grid in which you are going to place some cells, living cells, okay, at the start of the world. Okay, at the start of the world is t0. The world was started at t0. Okay, so at the start of the world you have a two-dimensional grid with some cells that are placed which are alive. Now in the next time point after, let's say, 1 second, that is, let's say, t1, okay, the world would have changed a little bit depending on the neighbors of the cells that you have. It might have probably more cells were produced, or some cells have died, or some cells have moved from one place to the other place. So that is what the whole game is. Okay, so the universe of the game of life is an infinite. You don't have to make it essentially infinite, but if you make it infinite, that's well and good. So it's an infinite two-dimensional orthogonal grid of square cells, each of which is in one of the two possible states. Either it is alive or it is dead. Okay, so each cell interacts with its 8 neighbors. So this cell, right, that we have over here, it interacts with the other 8 neighbors, okay, which are the cells that are horizontally, vertically, or diagonally adjacent. At each step in time, the following transitions occur. Any live cell with fewer than 2 alive neighbors dies. So a cell will die if in the locality of that particular cell there are less than 2 neighbors. So that is like, this is an alive cell, let's say, okay, and what is fewer than 2 live neighbors? So which means that only one among this, so let's assume that this one is alive, okay, and this is let's say dead, this is again dead, this is again dead, okay, this is again dead, this is again dead, dead, and dead. Now how are you? Okay, so that is my daughter, she is asking what is happening here. Okay, anyway, so yeah, so this is the cell that we are considering at present. Okay, this is the cell that we are considering. So this will look at all the 8 neighbors, and you can see that out of all the 8 neighbors, only 1 neighbor is alive. So that is less than 2 neighbors are alive around this particular cell, which means that in the next transition this guy will become dead. What about this guy? this guy also have to either live or die in the same transition. Okay, but in this one, right, we don't know the state of the other 5 neighbors it has, because this one will be looking at this one, this one, this one, and the other 5 neighbors around it. Okay, because it will be looking at a 3 by 3 area. So any live cell with fewer than 2 live neighbors dies as if by underpopulation. Any live cell with 2 or 3 live neighbors lives on to the next generation. So I'll just so let's say that this is alive, and we want to see what is going to happen. Let's say at T1 or Tn, okay, this is alive, and we are looking at the neighbors, and we see that there are at least 2 who are alive, and if there are at least 2 or more, right, that is the second rule. Any live cell with 2 or 3 live neighbors lives on to the next generation. Okay, so that means this guy will live through because it has 2 neighbors which are alive. Third rule, any live cell with more than 3 live neighbors dies as if by overpopulation. Now in this one, right, there are 2 which are alive, okay, and if there are more than 3 live neighbors, if it is either 2 or 3, see, if it is, this one was also alive, so for this particular candidate, okay, 3 neighbors are alive, which means that in the next iteration this guy 0 0 will also be alive. All right, this will be alive. Let's now assume this guy is also alive. So if we consider 0 0, right, we can see that from the neighbors, out of all the neighbors of 8 neighbors, 4 of them are alive, which means that this guy cannot survive further, because this has led to a scarcity of resources. Resources are actually scarce, and this guy will die in T n plus 1, correct? So the whole idea is that now we have discussed three rules. Fourth rule, any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. Wow, that is interesting. So which means that, let us assume that, okay, this guy is dead. So if we are looking at this particular cell, which is a dead cell, and we look at the neighbors, all the neighbors, we see that 3 of them are alive. If there are at least 3 neighbors, or there are exactly 3 neighbors who are alive, then this cell, right, will become alive at T n plus 1, correct? Do you guys follow what I am explaining over here? Okay?
Yes,
so,
sir.
Yeah, this is underpopulation, overpopulation, reproduction, right? And surviving, right? So with underpopulation you die, with overpopulation again the cell will die, okay? With right conditions the cell will live to the next generation. And this is any dead cell with exactly 3 live neighbors becomes a live cell as if by reproduction. That is the 4th rule that we have discussed. Now these rules, which compare the behavior of the automaton to real life, can be condensed into the following. So these are the rules, major rules. Now there are certain patterns, okay, that actually form in this game of life. So if you look at the game of life, you can see that there are some still lives, correct? There are some still life patterns, there are some oscillator patterns, okay, and there are some spaceships also in that. Okay, So there are still lives, oscillators and spaceships. So still lives means that if there is a block like this, okay, if there is a block like this in which these four are alive and the rest of the things are marked in white are dead, okay, there are no cells, there are no alive cells there. So this is, let's say these are the four alive cell. So this will be a multicellular organism. You can think about it like that. Okay, so it is like a multicellular organism with four cells, and this is called a simple block, and it is actually a block which will live on for n number of generations if there are no other guys who form around this white spaces. So that's a simple still life called block. Another thing is called a beehive, which will look like this, which means that in any of the succeeding generations this will not die and this will not reproduce as well. Then you have loaf, boat, tub. For the oscillator, right, if you have a pattern which is 3 horizontal cells or 3 vertical cells, then after every successive generation the cells will keep changing its position from like this. Okay, so that's called a blinker. Okay, period 2. I think it means that for every 2 successive generations probably it is going to blink. Then you have a toad, correct? So this is how the toad changes shape. Then you have a beacon. Okay, then you have a pulsar. This is a pulsar. Then you have a pentadecathlon, period 15. So this will undergo changes like this. So remember, where did we start this discussion from? I said that this is a cellular automaton. So it's like a emulator where you will try and figure out what is being done or what is happening in a world which actually started with the cells in these locations. What will happen at the 10th generation and so on. You have something called a glider. A glider will be like something like this. Will keep gliding towards one side. You can see that the grid is moving, right, which means that this guy is moving from top to the bottom right, correct? Then you have the lightweight spaceship. So this is called a lightweight spaceship, LWSS. Then you have something called middleweight spaceship. Then you have something called heavyweight spaceship. Okay. So then you have something called the gospel glider gun. I'm not sure whether this is actually shown here. Let me see whether it will be shown here. The gospel glider gun, right? It actually keeps on generating new gliders. That's the gospel glider gun. Okay, and so this is like if you look up it, if you read more about it, you will see a lot of things being shown. In your program, what will you do? In your program, all you have to do is you have to run this program. You have to obviously write a program. Oh, by the way, this is the single Gosper's glider gun, creating gliders, right? It will be something like this, which means that there are 2 blocks. There are some heavyweight and middleweight spaceships, which will keep moving, or which will keep changing depending on the generations, and with each generation you will have new gliders being formed. So that is the idea of this Gosper's glider gun. Do you guys follow what I have explained in today's class? This is a question for you for your assignment number 2. Okay, and the question is pretty simple. It's game of life. It's a simple game. It does emulate an organism and its evolution. So it's Saturday 19th. Students, can someone tell me, like, what are the things that you may have to program over here in this particular question? I am sure this question
Sir,
might.
program in the sense?
Okay, go ahead, Bhadraksh Bhargava.
No, sir. I am asking, like,
Yeah.
program in the sense, what do you exactly mean?
Okay, the question is you have to create the game of life program, right? Or the C program.
Sir, first we need the base or the grid to be generated.
The
Yeah, you
array,
can have a base grid that needs to be generated, yes.
a two-dimensional array.
A two-dimensional array. See, I can write this program without a two-dimensional array as well. I mean, I'm just giving you nudges so that you will start thinking how to do that.
Using nested loops, sir.
See, it can be anything. I mean, all I meant to say was you could have a two-dimensional array, or you may not have a two-dimensional array. Even if you do not have a two-dimensional array, you will still be able to program it, is what I am saying. Okay, now forget that. You can use whatever you want. You can use a two-dimensional array, you can use a three-dimensional array, or one-dimensional array, or no array. That is fine, up to you. Okay, so Atharva Sanjay More has mentioned that we definitely need a grid, and a grid is actually the reference. Correct, Atharva?
Yes, sir, the cells.
Okay, cells. Correct. Now, what do you need? You need iterations, right? You need generations.
A function to check through all the cells and determine the state in the next generation.
Yes, correct. Right? For example, if I told you, right? If I am considering this cell, right? These are the 8 neighbors. If I am considering this cell, okay, this cell, then the 8 neighbors are these 3 plus the 5 other neighbors, correct? Do you guys agree with me? Okay, let me create a
Yes, sir.
new page and insert a table. Let's say 10 by 10. Okay, so I have okay, so if I am considering this particular cell, okay, then it means that the cells that I need to consider are this one, are these ones, correct? These 8 ones that are around this particular cell. Now, if I am considering this cell, okay, second cell, okay, then the neighbors would be like this, correct? So, which means that, like Atharva mentioned, we have to now compute for every iteration, correct, right? For every cell we have to compute and we have to see what is the state, and then what do? We have to display this on the computer screen. How do you display that? Again, think about it, how you can. Correct, students? Now I will give you 2 more simple questions along with this, okay? Now these 2 questions, when I was doing my 11th standard and my 12th standard, I had taken computer science for my 11th and 12th, okay? So I had C programming in 11th and 12th, and I think C++ in 12th standard as well. So in the school, when I think that was in the year back in 2001 and 2 or 3, okay. So our friends, we discuss about different questions that we can implement, etc. And one of my friends told me there are 2 questions that are quite hard, but if you solve it, you are a pro in C. But obviously it was challenging at that time, and I did solve both the problems, and it took me some time. It took me I think about half a day just thinking about how to do that. Okay, looking at the mathematical formulation and getting how to do that. So that's the question. Now, what are the questions? So I'll create another SM also. So the question is like, first one, swap two numbers without using a third temp variable. So you have to swap two numbers without using a third temporary variable. So it's like, if it was in Python, I would say a comma b is equal to b comma a would do the work. If it is in C, then you have to do it as int a comma b comma c. Then it would be like a is equal to b. Okay. Then okay, I'll just put it as temp. It would be temp is equal to b. Okay. And then b is equal to a. Okay. And a is equal to temp. Okay. So this is how we would do it in a C program. What I am saying is that you should not use the temp variable. So you can have only two variables. You cannot use a third variable. But at the end, the values of a and b should be swapped. You can use only two variables. Okay. You should not use a temp variable. Okay. Second question is, given a number, a decimal number like 3.14 or 3.8, round it to the nearest integer without using the any if else or any math functions. So these are the two questions. Yeah, thank you. You guys have done that. That's very, very good. Okay, so this is pretty simple, right? So I'm actually happy that you guys were able to do that, but I'm also sad that you guys have actually taken away the time that other students must have put in to do that work. Correct? What do you think? So I'm happy that certain students were able to do the problem, the first problem. What about the second problem? Can someone try? I mean, if you know the answer, do not put it in the chat box ideally, because see, one thing that you need to understand here is that let's take a look at the number of students. Unfortunately, today only 46 students have joined. Okay, I do not know why. Anyway, but there is the whole class has around 75 students, correct? So the point is that you guys were able to do this very quickly, okay? Or either you may have done it by yourself. If you have done it by yourself, well and good. If you have copied and pasted it, not good. Okay, already consider it as a very bad remark. I mean, I may not be able to realize it. Okay, but that is immaterial. It is not your cunningness to make me, deceive me, or it is not your cunningness to deceive me that you should be doing. You should put in your effort to write it. Okay, now coming back to what I was saying, I am assuming that you guys have done this yourself. Now what will happen to the other students? So there are around 46 students, right, who have joined now, and the other students, because you have given them the answer right away, may not actually put in the effort to do the to come up with the answer by themselves. Now that is actually a great loss for them, because what happens here is that you are actually not thinking about how to solve the problem, right? I mean, the students who have seen the answer from somewhere, or the students who have not done it themselves, okay, will not be able to do it because they have not spent that time to do that by themselves. And until and unless they do it themselves, or they have spent that much time, they will not learn what has happened. Okay, so please try to do this, learn it. So this is problem number 2, this is problem number 3, and this is, of course, you know, problem number 1, I mean 2 and 3 are pretty simple, right? 2, the answer is already available to you now. So the first one is the game of life. So this is the assignment, CS101 assignment 2, okay, assignment 2, that you are going to submit by Saturday 19th. And these are the questions. First is game of life, second is swap two numbers without using a third temporary variable. You should not use the temp variable. Third question is, given a decimal number 3.14 or 3.8, round it to the nearest integer without using any if else or any math functions. So if else statements or anything should not be used. So the idea is that if you have 3.1, then it should print 3. If you have 3.49, it should print 3. I'm sorry, 3. If you have 3.51, it should print 4. Correct? That is what rounding means. Or 3.99 will be 4. Okay, students? Are you able to follow the questions?
Yes, sir.
Okay.
Yes.
By the way, this game of life, do you know where I came to know about it for the first time in my life? I came to know about this particular game of life when I joined a company called Gojek, okay, and when I was working there in Gojek. Okay, so this is a company, okay, where I was working earlier, and this was part of our training, etc. And during our interview we had a different question, a totally different question, that was to design a parking lot. I don't think these questions are here, but I think, yeah, it could be something like this as well. Yeah, asked in Amazon, Apple, Google, and many more interviews. Okay, so it was something like this. So we had to write a program which will design a parking lot. Okay. Now I think some students had asked me, questions regarding how we can practice more. Correct. So I thought of showing you that as well today. Just a little bit of questions that I thought I will share it with you. But once you go through the questions, once you look at the questions, you will be like thinking, wow, I know nothing of this. And that is the same reason why I am showing it to you today. Okay, this is your CS101 class, and I am going to show you some questions, and you are going to probably think that I know nothing of these things. Like, okay, there are questions, subarray with given sum, that could be very simple. Count the triplets, again probably simple. Cadane's algorithm, of course, we have to know what is the algorithm. Okay, then if you go further and further, right, you will see more different questions with strings, okay, with linked list, okay. And if you go further, right, you will see in the linked list itself, delete without head pointer, implement stack using linked list, implement queue using linked list, check if linked list is palindrome. Then you have something like stack and queue. So there, right, we have some questions like LRU cache. Of course, it's something that you may not know until you learn operating system. So there's a subject called operating system, okay. So yeah, and then you have tree, where you have binary tree, BST, vertical order, a binary tree in vertical order, lowest common ancestor in a BST, convert a given binary tree to doubly linked list, okay. So there you have to learn what is doubly linked list and all those things, right. Then you have heap, recursion, hashing, graph algorithms, graph problems. Then you have some greedy problems, activity selection, n meetings in one room, PowerPoint files, page faults in LRU. Then there's something called Towers of Hanoi. That is also another game. That can be solved by recursion. Yes, students.
What was the second question?
Second.
We had two questions. Question, which you gave. The second question, which you
Second question.
Yeah.
Oh, that I have given for the assignment.
Yes.
Okay. Did you get it?
Okay.
Okay. So, right, what were we discussing? Yeah. So we have different questions: road cutting, path in matrix, minimum subpartition, sum partition, egg dropping puzzle, optimal strategy for game, shortest common super sequence, binary search, quick sort, merge sort. Okay. Then search in a rotated array, backtracking. Okay, n queen problem, solve the Sudoku, rat in a maze problem. You can see that there are so many problems that are mentioned over here, and you should be wondering, I know nothing of these things, correct? I know nothing of these things, or I know very few of these things. Now that is exactly the same reason why I showed you this, because these problems are problems that you will learn in your upcoming semesters, okay, in the different programming, in the different subjects. Like there could be subjects like data structures, design and analysis of algorithms, okay, operating systems, and different other subjects that you will be learning. So you will be learning different things in that, okay. And you are going to use all of these things, if you want to get into companies like these big companies, etc. And but you should also understand one thing: without CS101 you can't do the other questions, because CS101 is where you will learn to program, and so programming base is the brick that you put at the lowest, at the foundation. Then you have the different bricks that you will have to keep on adding at the different semesters, and that is what will finally make you a good programmer. A good programmer is not just Fibonacci series or factorial and something like that, right? Yeah. So that's it, guys. I just wanted to show you that there can be any kind of question that you want to look into, say must do coding questions for companies like Amazon, Microsoft, Adobe, etc., right? So tricky programming questions, and you will come across different things over there, okay. So just to tell you that these are all the things that you are expected to do, okay. So these questions are fine, right? So game of life, swap two numbers using without using a third temporary variable. And where do you get more information about game of life? Just search on Google for game of life. Okay, just search on Google for game of life, and you will come across the first Wikipedia article. Okay, let's take a look at the second play game of life. Okay, so yeah, one more thing. When you start a particular world, you have to seed that world with certain certain cells, right? So this is a cell, okay, and if you start it, right, you can see that this cell will stay there all the time, and you can see that 20 iterations have happened, 24, 25, 26, and so on, right? Stop. And if I keep, let's say I'm going to keep still life here, let's see what happens. Wow. So that is the whole thing about game of life. Now in your C program, there will be a lot of limitations with respect to how you can actually represent the whole thing on your terminal. So think about how you can do it, and do the best representation possible by you. Okay, so you can see that this cells, right, I have actually put some cells in certain locations, and you can see that this is actually kind of moving, evolving over a period of time, correct? Let's see what happens. Wow, it's not always moving to one place, but it is actually moving, making some cluster at some place, etc. Okay, so that is the game of life that is expected, and in C program you can actually mention it with a star or a hash or something like that. Okay, where the cells are alive. So because you have only a black and white screen and you have limitations. All right, students, is that clear?
Yes, sir.
Okay. Jane, boy, I have class. BT. Okay, guys. So I'll leave the meeting. So Saturday 19th, you have to submit it by 6 p.m. I'll set it up on Moodle. So by 6 p.m. please submit it, and I want everyone to submit code. Those students who do not have a laptop, please try to do it on your phone. Okay, I do not mind even if it is an incomplete code, but a code is required. Okay, so please try and do that and submit it on 19th. Okay, Ravish and Akash, I think Akash Yadav, right?
Yes, sir.
Yeah. So please inform all your classmates about this question, because we do not have the full attendance today. So ask them to submit it by 19th. Okay. That's it, guys.
Okay, sir.
Yeah. That's it. If you have any questions, please share it through Ravish and Akash, as I have already informed you in your previous class. All right. Thank you. That's it, guys. Meet you in the next class.
Thank you, sir.
Thank you, sir.
Yes, sir.
വിളക്കിയോ വിളക്കണ്ട